Welcome back. Today we're untangling one of the most confusing topics for AP students, how object references work across an inheritance hierarchy. The whole lesson rests on one distinction, the declared type versus the actual type. And once you see it clearly, a huge category of the exam questions become very, very easy for you. Stick with me here. Alright, so lesson objectives as always, you'll learn to distinguish a variable's declared type from its actual type, understand why a subclass object fits into a superclass reference automatically, apply the golden rule that the declared type determines which methods you can call, and use casting safely while knowing when it throws an exception. These these objectives are the backbone of the whole reference topic. Alright, so this lesson hinges on one distinction, so let's nail it right away. Every object reference has two types. The declared type is what you wrote on the left of the equal sign when you created the variable. The actual type is the real object that was constructed on the right with new. These can be different. In the example, the variable is declared as animal, but the actual object is a dog. Both statements are true at the same time. Why does this matter? Because as we'll see, the declared type controls which methods you're allowed to call, while the actual type controls which version actually runs. Keep those two columns separate in your head, and the rest of this lesson clicks into place. So, why are we even allowed to store a dog in an animal variable? This is because of widening. A subclass object is a superclass object. So it always fits into a reference of the parent type with no cast needed. A dog is an animal, so animal X equals new dog works automatically. This direction, from specific up to general, is always safe and happens implicitly. The arrow in the diagram points upward to show that. This is the foundation that makes polymorphism possible, because it lets us treat many different child objects through one common parent type reference. Going the other direction from general back to specific is a different story, and that's what we have up for the next slide. Here's the golden rule of this entire topic, so let it sink in. The compiler decides which methods you are allowed to call based on the declared type, not the actual object. If your variable is declared as animal, you can only call methods that animal defines, even if the real object is a dog that has extra methods. So if a dog has a fetch method, but the variable is typed as an animal, calling fetch is a compiler. The compiler doesn't care that the object is really a dog. It only looks at the declared type. This is the number one source of confusion for students, so say it with me. The declared type gates which methods exist. The actual type only decides which version runs. What if you genuinely need to call a child-only method through a parent reference? You have to cast. A cast calls the compiler to trust you that the object really is the more specific type, which unlocks the type's methods. But the casting is a promise you would better keep. If you cast to a type that object actually isn't, the program compiles fine, but crashes at the runtime with a class cast exception. In the example, casting an animal that's truly a dog to dog works, but casting it to a cat blows up. The safe habit is to check with the instance of operator before casting. So widening up is automatic and safe. Narrowing down with the cast is your responsibility, and a wrong cast is a runtime crash. Oh, that's funny. No, it's not. Alright, let's see why all this is worth the trouble, because a parent reference can hold any subclass object. You can build a single array of the parent type and fill it with many different kinds of objects. Here, an animal array holds a dog, a cat, and more, all sitting together. Then you loop through once and call the same method on each, and every object responds in its own way. That's the power of building towards. Write the loop once, and it works for every current and future subclass. This is the practical payoff of the declared versus actual type idea, and it's the doorway to polymorphism, which is the very next lesson. Alright, let's try this. Which line fails to compile? Bird and fish both extend animal. Bird declares fly. Animal declares move. Pause the video and I'll let you try. Reference type is animal. Line 1, a.move is fine. Move is declared an animal. Line 2, a.fly does not compile. Fly exists only in bird, and the compiler only sees the animal API. Line 3 casts to bird first. So bird a.fly compiles and succeeds at runtime because it really is a bird. So only line 2 fails. Answer B. The declare type gates what compiles. Casting widens that view. All right, let's try this. Runtime behavior. Dog and cat extend animal. What happens when this runs? Pause the video and try it. Line 2 compiles. The compiler allows casting an animal reference to dog because it could be a dog. But at runtime, the object is actually a cat, not a dog. So the cast throws a class cast exception before fetch is ever reached. Answer B. A cast that compiled is not a cast that's safe. Always consider the actual object type and use instance of to guard it. All right, let's pull the ideas or the key ideas together. Every reference has a declared type and an actual type. Widening, storing a child in a parent reference is automatic, safe, you're good. The declared type controls which methods the compiler lets you call, while the actual type controls which version runs. And casting down is your responsibility, with a wrong cast crashing at runtime. Hold on to these, and the next lesson on polymorphism will feel like a natural continuation. Nicely done, guys.